The goal of this video is to give you a bit of an introduction to LaTeX, which is a language for typesetting mathematical writing. LaTeX editors exist for every platform, so I encourage you to explore what tools are out there and what works well for you. I personally like to do my LaTeX editing in the Tech Shop program on a Mac laptop, but the tool I'm going to demo is Overleaf, which is a free web service and therefore accessible on any platform, and which also allows collaborative editing. You'll need to create a free account at overleaf.com, and once you're logged in, you can create a new blank project. And upon creating a project, I get to a screen with two sub-windows. On the left-hand side is the LaTeX source, and on the right-hand side is the rendered PDF output. To create a document with LaTeX, you add text to the source file, and then you compile that source file to produce a document. The basic structure of a LaTeX source file is it needs a document class, which for our purposes will essentially always be article, and then we will have begin and end commands for the document. And if I compile this, it fails because there is nothing in my document. But if I add some text and recompile, I now have a one-page document that contains only that text. If we go back to the defaults that Overleaf gave us for a new blank document, we now see that there is some stuff that comes before the beginning of the document. This is the Latex Preamble, and it's where you can do things like setting up the title and author information, but it's also where you can import packages, and there are LaTeX packages that allow you to do all kinds of awesome things. If I recompile this, I get an output here, but I also notice that there's a red 3 here, which is telling me that there was some error in the compilation. And the source of its complaints is that I have an underscore, which was added by default based on the name that I gave to the file. And if I replace that underscore with a space, now all of those errors have gone away. The reason that that was an error is that underscores in LaTeX are a special command in math mode for creating subscripts. And so the LaTeX engine was upset that I had an underscore outside of math mode. If I wanted a literal underscore character, I could do \_. So the rest of the preamble here, the title, author, and date, are inputs to the make title command. And so this make title that goes inside the body of the document causes the title and author information that I gave to be included in the output. If I comment that out, LaTeX comments are with a %, then I no longer have title and author in my document. The default also gave me a section heading, and I can add some text under that section heading. And I can add a subsection within the section. So LaTeX has automatically numbered my sections, and it has detected a paragraph break between lines 14 and 16 of my source. Now it's worth noting that the text that you get in the compiled output can look very different from what you typed in the source file. And this may seem weird if you are thinking in terms of a document editor like Microsoft Word. But if you think instead in terms of LaTeX being a programming language that we have to compile to produce our visual output, then it makes more sense that the compiler is doing a lot of work to render a PDF of our text, and we will see later that that gives us a lot of power, but it also means that we have a little bit less control over some of the ways that our text gets spaced. In particular, There are only two types of white space that LaTeX recognizes in the source. There are sequences of multiple consecutive new lines, which it treats as a paragraph break, and there is everything else. So if I have a single new line, note that those in my output got turned into spaces, because all white space except a double new line gets treated as the same. So whether it was many spaces or a tab or a single new line, those all render the same way. And if I have many new lines in a row, that renders as just a single paragraph break. So because the LaTeX compiler is trying to typeset your text nicely, if you want to do other things with the spacing, then you have to use particular commands for it. There are commands that allow you to, say, add space between paragraphs. The vspace command adds vertical space, and you can give it a distance. So I could say I want 15 millimeters of vertical space between these. And similarly, if I wanted to spread these out on opposite sides of a line, I could use hspace for horizontal space, or I could use hfill to fill up all of the available horizontal space. And then the text goes to opposite sides of the line. Particularly important in terms of spacing in LaTeX, if you are trying to type code, remember that all of the white space in that code will be gobbled up by the LaTeX compilation. So you can use a verbatim environment in order to have it render verbatim the characters that you have typed. And so now I could do something like, in a verbatim environment, to render it in a monospaced font with the literal spacing that I typed, and that's useful for code. The real value that we get out of LaTeX comes when we enter math mode. So there are a few different types of math mode, but all of them have in common that they are really good at rendering equations. So if in the middle of a sentence I want to have some mathematical notation in that sentence, I can add inside dollar signs some math notation. For example, I can do, and so I can add in mathematical notation like for all x in z in the middle of my text explanation. Better yet, I can turn my z symbol into one that is more appropriate to represent the set of integers with the math blackboard version, which I need to import a package in order to use. So in all of your assignments for this class, I encourage you to use the packages AMS math and AMS symbol. And now if we zoom in on the PDF, we see that we have rendered our z for the set of integers appropriately. So we use a single dollar sign to surround inline math mode, but we can also do display math mode. So I'm going to copy to create another paragraph, and in between those paragraphs I'm going to do backslash open bracket, and then I'll end with backslash close bracket. And this puts what's in between into display math mode. And display mode pulls the equation out of the text and puts it between two paragraphs. And this is very useful for showing more involved equations with subscripts and superscripts or fractions or other features that require a bit more space. So for example, I might do so we see that underscores give us subscripts and carets give us superscripts. And so when I put a subscript and superscript on a sum, those give me the start and end of the summation. And when I put a superscript on just a number, then that renders as to the power of. I can also make fractions, and there are tons of other features for rendering equations in a LaTeX document. Another handy type of math mode is the align environment. So in display math mode, these double backslashes force a new line, but for this to be clear to the reader, it would really help if the left and right-hand sides of these equations all lined up. And this is what the align environment is for. I can put an ampersand on each line at the place that I want them all to align based on, and when I recompile, all of my equations line up nicely based on that equal sign that I labeled with the ampersand. Here's the result of the align, but not hidden behind my video. So you've seen a few handy math symbols like for all, or blackboard writing, or fractions, sums, square roots. But over the course of the semester, you will encounter many other symbols that you want to typeset in LaTeX. And so to figure out how to type a particular symbol, the website or Android app Detechify is extremely handy. If you Google Detechify, you'll get to this website. And now I can click and drag in the box. And if I want to make a squiggly equal sign, it tells me that \approx, when I'm in math mode, produces the symbol that I want. Or if I want to know how to make the set intersection symbol, it tells me that \cap in math mode is what I'm looking for. One thing you may notice about this document I have on the right-hand side is that it has really big margins. This can be nice for readability, especially if you are writing big blocks of text. But often in this class, we will have documents where we're solving a number of separate problems, and so we won't need the enormous margins to make our text readable. We can rely on the separation of short problems to do that for us. In that case, it's often handy to use the full page package. And this will reduce the margins down to much more like what you're used to from other text editors. And in most of the handouts that I give you, I will already have included the full page package. So there are tons more things that you can do in LaTeX. And while it is a learning goal of this class for you to get familiar with LaTeX, it is not a thing that I will be explicitly testing at any point this semester. And so you are free to Google anything you want about how to do things in LaTeX, and I strongly encourage you to do so. There is tons of great advice online about how to do things in LaTeX, and if you find the right keywords, you will almost always find an example of somebody doing something similar. So for example, next week when we talk about Boolean algebra, you'll definitely want to put some truth tables into your LaTeX document. And so you can Google how to make tables in LaTeX. And this first result from Overleaf seems like a good one. And I can then take a look at a few of these examples and pick one that seems appropriate to what I'm trying to do. Let's copy that over into my document. And we'll recompile. That's awesome. But maybe for my truth table, I actually didn't want a line at the top, and I wanted a line after the first row. But it's clear that this H line is how that's being created. And so I could move that to after these first few cells and recompile. And yeah, that's what I was looking for. And so now I can do... And now I can start filling in my truth table. So this approach of find something similar, like in this case a basic table, and paste it into your document and then turn it into the thing you want, is a really common way of making things in LaTeX. Another command that you'll definitely find useful this semester that's provided in the AMS packages is the Theorem Environment. Huh, it looks like that gave us some compilation errors, and it's complaining about the theorem environment not being defined. And a quick search shows that I have to declare the way that I want my theorems to be labeled. And so we can do that. And maybe I want them to be abbreviated THM instead of theorem. Now I compile, and it knows that this was the first theorem of the document, so it labels it Theorem 1. So hopefully this has given you a bit of an idea of how to get started with LaTeX, but what I expect to be perhaps even more helpful is taking a look at the example documents that I will give you throughout the semester. In particular, for all of our in-class exercises and for all of your homework assignments, I will be giving you the LaTeX file that I used to create the assignment. And in the case of homeworks, you should use that as a starting point for creating the document that you will eventually submit. And for the in-class activities, you should absolutely take a look at those to see how was it that I did a thing that you might want to do in your own documents. As I said, there's also tons of additional documentation online through Overleaf and through Tech Stack Exchange and through many other resources. So I strongly encourage you, if you think there's a thing that you want to do in LaTeX, search for it, and there's almost certainly a package or some other way that you can get it done.